Welcome back. Welcome back to yet another video on Java interview series. So today we are going to discuss about one of the interview which I have attended uh, for Java Spring Boot Microservices interview. So this was the company called Cognizant. If you have heard of, it's a multinational organization. So I have attended the L1 round. So people who are preparing for interviews, whether it is software engineers, whether it is Java developer, whether uh, for any senior technical role, right? So this interview would be helpful. These are the real questions which were asked in Cognizant interview. So I want you all to closely uh, watch the video till the end. So I will be explaining what questions they have asked and what would be the perfect answer for it. Okay, so let's get started. So the very first question which they normally ask for any candidate, right? So when when he submit the resume, right? So the very first question which interviewer try to ask is about, tell me about yourself. Now when this particular question comes in, right, you try to answer it like, what is your experience, education, what is your experience, right? And what what are you currently doing, and how are you contributing, right? So you have to explain about your I mean, the project part will come later, but in the question, subsequent question, he may ask about tell me about the architecture or etc. all details. Then if he asks, then you have to answer those. But ultimately, you have to ask, you have to tell your details about your education, your experience, how many experience you hold, what technology stacks you have worked, what is your project is about, right? So you can tell over that. So let's move on to the very next question. So some interviewers normally prefer to ask, to understand what was your team size, how was it structured, uh, in many organization, right, they have junior levels, senior levels, and then leads, and then we have a senior tech lead, and then we have a project managers, and then there is another side to it, we have client facing roles where we communicate directly with the clients, right? So they will try to understand whether you have a real experience, and then they will give you they will ask you about how many team members were there, what were you doing about that, how you used to take the requirement, how many sprints, right? How you used to deliver your work, right? Code review and other stuff, details, what all practical questions which might be asked can be asked over there. So be well prepared for it. Now, the very first question which he asked me about was, what is concurrent hash map? And basically, it doesn't stop here. What happens is that when you answer this, what is concurrent hash map, and there may be multiple questions around it, right? So if you see here, I've written what is concurrent hash map, internal working of an concurrent hash map, what is the concurrency level in the hash map, how many threads can be run at a time, right? So these all questions may be the subsequent questions. The very first question, he might ask you what is concurrent hash map, and how it is different from normal hash map, right? So that might be the question here. Actually, when I was asked is about these all four questions were asked subsequently after the one, right? So what he asked me is about what is concurrent hash map. So basically, concurrent hash map is nothing but a thread safe implementation of an hash map, right? Hash table or hash map, right? So it is similar to that, and it can handle multiple concurrent read writes, so it's very much efficient than hash map, right? So what happens is that ideally, what you used to do is that you had a hash map, and then what you used to do is that to make it synchronize or thread safe, you used to call one method, that is collections dot synchronized map, so that in that case it will make it as an synchronized. But in that case, what it used to happen is that the whole object used to be locked up. So any thread is trying to acquire that particular log will have to particularly take the log, and then it should wait to complete that particular read, right? But here, in case of concurrent hash map, the case is different, right? Uh, it's segment based. It is locked at the segment level base, and thread can act on it, right? So we'll discuss more on that part. But what exactly is the concurrent hash map? As I said, it's part of the Java util package. So it is designed to allow multiple threads to read and write the modify the concurrent hash map, right? So without making acquiring the lock. So for the entire map, as in the case of hash map, right? It was entirely locked up, right? So this is not the case with the concurrent hash map. So it will be only it is divided into the segments. It the only that segment will be locked up when it is trying to write up, right? So read can happen anytime, multiple times, like there will be no problem. So what happens is that in this particular scenario, it is significantly improving the performance, right? So when you're trying to, it is partition the data into the segments. Like as I told you, like there will be different segments. So which will what will allow is that that threads which are trying to access, right? It may access without locking that particular whole concurrent hash map. So it will be only locking that particular segment. Okay. Now the second question which ultimately comes up is that now can you tell me the internal working of an hash map? So earlier when there was no concurrent hash map introduced, uh, the interviewer's favorite question used to be like what is hash map, and like can you tell me the internal working of hash map? Now with concurrency package being added, right? So they also wanted to understand like whether you have a deep understanding of concurrent hash map, right? So what happens is that as I told earlier, so concurrent hash map is divided into a multiple segments. It is also called as buckets. Okay, so there are different levels buckets over there. So each segment or each bucket can be locked up, so that this can be independently locked up. So there are, let's say there are 16 of them, right? So each one of them can be locked up independently, so that multiple threads can read, write, and operate on a different level, right? So that doesn't have to wait. So the locking mechanism inside this is only the specific segment is locked up. There is nothing like the whole map is locked up, right? So that it will reduce your operation time out there. So one another benefit of is that non-blocking read. So what happens is that when you're trying to read, right? Usually, like it doesn't need to acquire a lock for making reading it, right? So that makes it very faster to read those. You doesn't have to make wait for taking the log and then try to read it, right? So that's the benefit. Now the structure of this particular bucket after like the Java 8, right? So it has been earlier, like earlier it was only the linked list, but now it has been in the combination of linked list and the balance tree. So what happens is that there are collisions, right? So it is actually let's say too much of collision is happening, like in the same bucket, like same segment, there are too much of objects are being inserted, like this will it will enhance making the use of the balance tree, right? So the number of entries which are exceeding at a certain threshold level, let's say example 8, right? So it normally earlier in hash map it used to be linked list, right? So it used to be linked list, but now it has to be changed after in Java 8, right? It has to be a balanced tree. So it is quite efficient. It is quite improved when it comes of handling those particular performance level, right? So hope you got this particular point. Then now, when it comes to like this is the continuation part of the concurrent hash map question. So the one another question, what normally it's very rare, but they normally try to understand if you have a deep understanding, if your experience is above like 5 years, 6 years, or 8 years, right? So they will try to understand like whether you have an understanding of the concurrency level, right? So what they will ask is that what is a concurrency level in a concurrent hash map. So basically, uh, what is concurrency level is that the number of threads that which can modify simultaneously, right? So without being hindered or stopped up. So that is what concurrency level, like how many threads can act on it. So this it is determined with the number of segment that is there in the map. So the default for the concurrent hash map is 16, right? So this means like there will be different 16 segments by default, and 16 threads can write concurrently over there. So they it will be very efficient to read and write over there. So if you see, like, I have written a code over here. So if you see it, so there is a map which is concurrent hash map. So it will have the initial capacity, the load factor, the concurrency level, right? So these all details are required when you're trying to create. It's not mandatory, but if you're not providing these particular details, so this will be by default added. Okay. uh, we have, how many threads can be run at a time. So basically, if you got an answer in that, like there are 16 number of threads, right? So what happens is that the reads can be happen at without blocking or without blocking, right? So there can be multiple threads which can read the data, but ultimately when it comes to write, right, so we can only modify the concurrent hash map in a limited number. That is, there are 16 segments, right? So what will happen is that we'll have to acquire log for that particular 16, and then we have to write that. So 16 threads at a time can modify those 16 segments. So if there are more threads, they have to little bit wait on that part, but ultimately 16 threads on particular that block will, segment size, it will be locked up and then write it. So if two threads are trying to attempt the same segment, one has to wait until that it is released. Okay. So ultimately, when it comes to the whole summary, what exactly concurrent hash map is about, and what exactly it does is that the basic benefit is that it's highly used in the multi-threading environment. So if there is a law benefit of high, it's a high throughput, right? So it supports that. Now avoid, it avoids the bottleneck of we have to just synchronize that particular block of the map, and then we can take acquire lock, and then whatever perform it, right? So locking and then on releasing, it's quite as it is a segment level divided, right? It's quite efficient in terms of read and write. So it's non-blocking, so you doesn't need to acquire any lock when it comes to reading, right? So it's quite efficient. You doesn't need to wait in terms of reading also. Okay. So this is all about concurrent hash map. Hope you got the crisp details about, when you're in an interview, you'll be asking about what is concurrent hash map. I've given the whole details about internal working, what exactly the concurrent hash map, how many threads are there, right? The concurrency level, etc. Let's move on to the next question. What is how object is garbage collected in Java 8? Now prior to Java 8, there was a different way of being garbage collected, and after Java 8 there is a different way of being garbage collected now. But basically, before that, going to that, we'll understand what exactly the garbage collection is about. So it's a process where the objects are recycled, and those are cycled, so that those memory is freed up for the next objects which are getting cleared up. So there is a process which runs at the background in the JVM, right? So it cleans up any objects which are not being used or marked as, and to clean up, right? Those will be cleaned up so that it will be available for the next set of objects. So in Java 8 and later versions, right, it is handled by JVM automatically, right? So what happens, it reclaims that just those memory by removing those objects from the that are no longer reachable now. Okay. So there are different garbage collections, which is used, G1 garbage collector, G1GC, right? It is called. So this will actually this has improved significantly when it comes of in terms of recycling those particular object, right? So what happens is that when it comes to uh, when you object creates when you create an object, right? What exactly are the steps happening inside the memory? I will try to explain that, right? So what happens is that we'll see, how object the allocation happens in the memory, like what exactly it happens. So when you directly create an object, right, it is initially created in an Eden space. So now basically the memory, if you see, it is divided into an Eden space. Then there will be a minor generation or a young generation, right? And then there will be a old generation. So what happens is that uh, the the objects which survives, one or two level of cleanup activity, right? And they are still alive, right? Those will be moved to the next the old generation, right? So that they are living for a long time, they are still used up, and somebody is referencing it. But those which are in the one cycle or second cycle only, those are cleaned up, right? Those memory will be available for the next set of objects, right? So what happens is that when we create an object, it goes to the first Eden space, right? That is called as a young generation. So now in that there are minor level of garbage collection happening. So that what happens is that let's say the Eden space is full, okay? So what is that? The minor GC will be triggered, okay? So those objects which are not referenced in the Eden space, which will be removed slowly, right? So those will be the objects which will be cleaned up. Now there will be another objects in the same category where those objects are still being used up, and they will be surviving. So what happens is that there will be another minor garbage collection happening. So those things will be again removed, which are not referenced, and then which are still referring. It will be ultimately with this 2-3 minor cycle, life cycle of surviving it, right? It will move to the old generation. Now what happens is that now this earlier it has happened the minor version, which will clean up all small objects, or which are available, right? But there is an old generation, as I told you, it's a permanently spaced, right? So after all, they have reached to the old generation, right? So what happens is that there also the cleanup major garbage collection happens. So let's say after a multiple life cycle, it has reached there, it has been stayed for a long time. Now this particular object is also is available for garbage collection. So what happens is that the major garbage collection tries to clean up the old generation, where the object sits over there, and it is no longer reference. So it will clean up that as well. So ultimately that particular things will complete the, I mean, the object will be completely removed from the whole the system. Now when it comes to types of garbage collector, this is, as I told, the cleanup activity is done by the garbage collector. Now there are different type kind of garbage collector when it comes to in Java 8 and later versions, right? So serial garbage collector is there, parallel GC garbage collector is there, concurrent mark sweep collector is there, right? And then G1 GC. So this is one of the default one. So um, I will discuss this particular in a separate video, but I think these are the different garbage collections available to us. Now the steps I told you, right? So basically, how the cycle, how it happens is that first it initially marks which all objects are still alive in the old generation, right? And then eventually it stops, right? It ultimately stop those which are not I mean the programs, I would say, okay? Now, in the concurrent it will mark as an concurrent user. So it will again scan the heap to identify if there are any objects which are live. So it will run this particular to concurrently see with the help of this particular thread, right? Now finally it will mark it. It will complete the marking process, right? And then it will clean up the references. So there are different soft, weak, and phantom references based on how the objects are being referenced, right? Now ultimately the cleanup activity happens. So it will actually reclaim all this particular garbage collection space so that it can be made available to the next set of objects. So only those who are surviving, right? It will be it will be available in the heap space. uh, Hope you understood the brief information about how garbage collection works, and how when an object is created, what happens with the and what garbage collection does when it comes when the objects move from one location to another location, or it survives, right? Hope you got this particular information and it was helpful. Thank you. Now let's look at the another question: how we can garbage collect an custom object which have been created by us, right? So basically, like, they wanted to understand what happens when you try to nullify, or like, if you override the final method and other details. We'll look into that in the details. So in Java, you cannot explicitly, I mean, earlier when you directly call any like system.gc or any other thing, it will not be explicitly called up. So it has its own time, like, it will decide and then it will run. So it will not, you cannot force that to garbage collector to be run. So you can make that particular object as an eligible by making it by null, or if it is no longer reachable. We'll discuss about the steps for making it, the object eligible for garbage collection. First, the first step and like very first way of making it is that we have to mark it as null or make it as null. So I've just written a small code over here, which says that we have to set that particular object to null, so that it will not it will not be referenced, and also it will be marked as an null, and the garbage collector will make it notice and it will try to remove this. So making it, earlier we have make use of it, now we have marked it as null, so that when you're calling that system.gc, or like itself, like the garbage collection is triggered by the JVM when there are memory is full, it will look all for all null objects, or the objects which are weak references, like which are not being used up. It will clean up that. Okay. The second step is reassign the reference. So what happens if you try to create a new object which to an already pointing to a different object. So the earlier one, like, which was already created, right, is no longer referenced. So that object will be automatically cleaned up from the memory. Okay. So now if you see in the example, it was my object. Now let's say in the same object, I'm trying to create a new object of it, right? I mean, earlier one, what was it is created, right? It will be garbage collected, right? So if you see, like, when you call that particular system.gc, right, it will mark it, though it is not immediately will be called up, but ultimately it will be marked up, so that this will be picked up by the garbage collector. Third point is like object inside the method scope. So what happens is that the method which is written, right, it has got a start and end, right? So whatever objects which are created inside that particular object will have a narrow scope. So which are object which are created inside that particular machine, it will, once it is completed, that will be no more longer available, right? So you call that particular create object method. Let's say example, I've created a new method over here, and inside that I have created an object. Now once this particular create object is executed, it is again eligible. Now this object is not there referenced, right? The work has been done for it, hence it will be eligible for it. Now dereferencing the cyclic dependency. Garbage collector always, like, handles the cyclic dependency if you don't explicitly need to I mean, you doesn't need to explicitly write that, break that. So here if you see, the code is written over here. There is a node, and then we have node 1, node 2, then the node 1, the next, and then the next of node 2. Now ultimately, if you see in N1, I've made it as a null, and then N2 has made it. Now both objects are eligible for garbage collection. Now we make use of this particular. We created an object, we made use of it, and then we nullified it. So it will be dereferenced. Now it will not be a reference, or like any object is not pointing to it. The final summary about the garbage collection is that although it is not recommended to call the garbage collection GC methods, but basically if you wanted to explicitly call, ultimately it is JVM will decide when it is going to be called up. But you can actually the methods has been provided by the Java. So there is a system class which has got a GC method which will ultimately trigger Uh, Also, there is a runtime that is got a get runtime method which will call the GC method. So ultimately, uh, this will try to trigger when or it will indicate that where there is a garbage collection needed. But ultimately, JVM will be the right in the right position to run those particular when it has to be run up. So as I already informed, it is not. It's an automatic process. It will not be. You cannot force it to call it, right? Now all the objects which are garbage collected and unreachable, right? It will be eligible for garbage collection. You can call system.gc. I mean, you can only request it, okay, to the JVM to perform garbage collection. It will not be guaranteed that it will be immediately executed. uh, there are some profiling tools like visual aim to understand, like how to monitor it, how to debug the memory in your application, so that you understand, like what memory object is being used up. Look at the another question. What is solid principle? This is one of the most frequently asked for the experienced candidates. You will rarely found this particular question at the if you are like a fresher or 2 3 years experience. But ultimately, when your experience grows up like around 4 years, 5 years plus, right, you will definitely see this particular question in your list. So they try to understand whether you are following the solid principles, dry principles. There are some principles when it comes to software development which are followed for clean code, scalable, and better writing of your code, so that it is easily maintainable and scalable. You doesn't need to worry about like um, what is to be done, right? It will be structured, it will be scalable, it will be maintained, so that it will be clean code. uh, what exactly is like solid principle? So it's a set of principle, as I mentioned, uh, in the object oriented programming, so which will help to create a basically a system to easily maintain, extend, write code, a clean code. So these were introduced by one of the guy, Robert C. Martin, okay, uh, which has been widely adopted by many organization. Like it is followed as a standard structure, and like uh, it is referenced as an quality of the software design. The very first letter which indicates about like the solid word, it is single responsibility principle. When you design a class, or basically you have one component, right, or a class which should only be doing one thing, and there should be only one reason to change it. You can only do one thing at a time, or like functionality which is intended to do. You cannot clutter that, or you cannot impulse the different responsibilities or activities inside in one area. So that what will happen when you try to, let's say, you include multiple things, right? So there will be one change, so you have to, in order to make that particular change, you have to in fact change this particular original, right? So it should be minimally impacted, it should not affect the other code, so that there will be less bugs or less code changes which is happening to it. So you should write your code in such a way, you should design your class in such a way that it should only have one reason to change, and also only it does a single responsibility work. There is another principle which is called open closed principle. uh, it's it's an entity, is like in the software it is an entity which is basically like you should be open for extension but closed for modification. So basically this principle indicates that it should be allowed to extend and then do your modification, keeping intact the original thing, you doesn't need to modify the original. You can extend it and then write your own implementation. So that's clearly separates your logic, and then you can have your own specific logic over there. So the uh, doesn't introduce, let's say this component is written right, it's well tested. You doesn't need, you if you touch that particular code and write something which might introduce some bug, so it stops that. You definitely write your own implementation there. Actually you can test it and then made it available. Hope you got the second principle. The another one is Liskow's principle, the substitution principle. uh, there are superclass and subclass, right? So objects which are created for the superclass, right, should be easily replaceable by the objects of their subclass. If you have uh, worked on Java, you must be knowing the concept of inheritance. There is a superclass, there is a subclass. So we can actually assign the subclass object to the superclass. We can actually replace that, right? Without impacting the code. You doesn't need to worry about it. So that's the principle about the list course principle. You should be easily replace your super type with these sub classes which is implementation of it. So there is a contract basically with the super class what exactly the implementation would be about. So it should not break your code basically. So it is written in such way that inheritance is designed that it doesn't break your functionality. Interface segregation. So ultimately this principle is about the one who is going to implement your functionality. It should not force to implement unnecessary thing. So only let's say you have an interface, right? So only the required interface with the required set of methods should be implemented. Let's say you have a very big interface, like it is designing, it is doing a lot of stuff which is irrelevant to the one who is going to implement it. So now he doesn't want that particular functionality. He has to unnecessarily implement those particular methods and implement it, right? Instead of that, your interface should be designed with some specific goal, and like it should be doing a single specific thing, so that the implementation should only extend the specific and the required one. So create smaller specific interfaces which will be crisp for that particular specific one instead of the general purpose one. So this will ensure that you have a crisp implementation. You are implementing the required functionalities, not the unnecessary. Uh, the last one is dependency inversion principle. This basically the high level modules which are there, right? This basically should not be dependent on the lower module. So it should be completely abstract. So both should you should depend on the abstraction. So what happens that we have an super class and then we have an implementation, right? Or we have interfaces and then the implementation. So interfaces should not be dependent, or the super should not be dependent on the implementation. We should be instead the you should be making use of this particular interface. It is to be quite abstract, so that it is very flexible to write the code on it, new make implementation of it, and then you can test it. Okay. uh, so that's the benefit of dependency inversion. Ultimately, if you see the benefit, what exactly this solid principle as a set brings in when you follow this principle. So one is like it improves your code readability. It's quite small focus class and interfaces you design over there. It's better maintained. It's easy to debug, and then if you need to do any modification, it's quite easy. Now it's quite flexible when it comes to following this particular solid principles. You can add new feature. It doesn't break your existing functionality. and making use of this inheritance, like we are using the recomposable component, reusable component. So we define once and then we use it. We are actually completely abstracting it, and then we have an implementation of it, right? So we are trying to use that code reuse. We are promoting that particular reusable functionality. Hope you got this particular question. Let's look at the another question. What is marker interface and when exactly it should be used? So this is one of the core questions any interview will ask to test your Java knowledge. It's not specific to any Java 8 or any version, but marker interface he will definitely ask if he wanted to understand about interfaces. So your knowledge on the test and Java. So what is marker interface? So interface is special type of an interface. So in Java, which it's a special type of an interface which will have no methods inside it and no fields also. It is primarily used for making or marking a class for some special behavior or a property. So make an to JVM understand this particular class is of some special type and should be taken in a different way. So there are different kind of marker interfaces available. If you have worked on JPA, you must have heard of serialization or serializable interface. So entities which are marked as in serializable, those only will be persisted. So JVM understand that this particular entities are serialized, and we have to make it as special, and then we'll persist it. So there are examples of serializable interfaces. One is serializable. Examples of marker interface. One is serializable interface, one is clonable interface, and one is remote interface. So if you see serializable class, when you make it as an when you implement those, right, so it will be converted to a byte stream. So the one process from serialization to deserialization is called converting from object to the byte stream, so that it can be recreated. Clonable. So by implementing this, you are making it you are bringing the property of by it will be copied one by one, and it will be copied field by field, so that it will be creating the object exact copy of it. Remote. If you have worked on EJBs, there will be different it will be considered as a remote interface or remote object, so you can work it in a distributed environment. Why basically we need an interface, marker interface specifically? The very first reason is like you wanted to tag a class. It should be eligible for certain features or behavior when you're trying without you having any implementation. So when you're marking it as an serial extending or implementing it, right, so it will be marked on that part. Second reason is checking the type of that particular at runtime. So JVM allows to check this particular object is of type at runtime. It will check that in a specific type or not. So based on that, it will perform certain operation. As in serialization, it will persist. For clonable, it will clone. It will for the remote, it will be work with a distributed environment. So every interface is intended to do some different behavior. So if you see, as I mentioned, like this three, four interfaces have their own different set of operation and functionality. Framework or library customization, so we can make use of we can create custom interfaces, and then we can define the specific behavior. There is a different a process of creating it. When to use the marker. So using marker interface, you need to be very clear about what exactly you want that certain
property to do, or it behave like. If you taken here, there is an example like custom marker interface, which will be like auditable. So all the classes which are going to implement it will have the auditing capability. So you want certain behavior based on the marker interfaces. So you implement the serialization, so it will enable serialization. Similar way, if you implement clonable, it will enable clonable thing. So you should be making use of this particular um, compile time safety of it. So you will be able to use it, right? So it's quite easy, and it will be quite handy for the JVM to understand if you are marking those particular interfaces, right? Um, so you doesn't, you need it to listen as a summary. You can mark that particular interfaces when you need to come that compile time safety, or when you are working with certain frameworks like serialization and etc. We can also follow the approach of annotation. It was quite flexible, so that you doesn't need to do that manually. Hope you got this particular marker interface concept. This is one of the multi-threading section question. It will be asked in when you have, the interviewer is trying to revolve around multi-threading. Basically, you will try to understand you are having a hands-on experience on multi-threading. Uh, and in general, if you see, this is a concept of synchronization where you are acquiring a log of a certain class or an object, right? How it will happen. Now, if you go with the term of lock, right? In terms of Java, it is something which is it's a section of the code where it is completely synchronizing that particular code, so that multiple threads are trying to control that particular section. So it will give a controlled and section, so that multiple threads cannot access that. uh, it will allow only one thread to execute that at a single time. So you have to write a particular code or a section of code which will be accessed by multiple threads, but it will be only accessed one at a time. Okay. There are many different situations when it comes to acquiring a log. There is a deadlock happening, right? So the very basic thing is that you should able to acquire that particular log on a certain resource, so that you can do some operation on it. Now there are types of logs in Java. One is intrinsic and one is explicitly log. Uh, so basically, if you go with the intrinsic log, right, these are all provided by the Java. So they are associated with every object. So using like synchronized keyword, we can make use of the intrinsic log. Now, explicit log, there was a concurrency package introduced. So if you see Java util concurrent log package, so it's quite flexible and powerful when it comes to uh, comparing with the intrinsic log to the explicit logging, where you get more control and more features when you are working with an explicit logs. So it is provided by the lock interface, and it is got the various implementation like reentrant lock is there. Different locks are there. This the reentrant is one of the example of it, where you will be able to do certain kind of locks over there. Now, manual lock, we can actually have to lock and then unlock, right? It will be uh, used there. When it comes to differences of this particular there are different kinds of lock, I would say. So as I mentioned, one is recurrent lock, one is fair and unfair lock. Now there is deadlock, and then there is a try locking. So we'll definitely look into this particular concept at the very later videos when I'm trying to make a video on the lock. But these are the different locks available. In terms of comparison, when you're trying to do what exactly the intrinsic and the actual explicit log. So if you see, uh, these are all like when it comes to comparing the intrinsic with the reentrant or the explicit lock. So intrinsics are used for these are all built in. Now these were when it comes to uh, lock, which is explicit lock, right? It is not part of built-in. It is like there is a part of it's already a part of built-in, but it's part of a separate package that is Java util concurrent locks. Now, when you are making use of and synchronized, it is automatic when it is entering that particular synchronized block. When it comes to lock, right, explicit lock, we have to explicitly lock it and then unlock it, and we have to perform that particular operation. Uh, it's not a fair thread when it compared to synchronize and the thread compete. But here actually you can actually it's quite fair that when you can specify the way how should be acquiring the lock. This particular synchronization, when it comes to interrupting the lock, it's not interruptible. But lock, if you see, it supports interruptive locking. Try locking, this is one of the locking mechanism which is not supported when it comes to synchronize, but it is supported using the try lock mechanism. Now, when it comes to synchronization, we have a concept of wait notify, right? So one thread is acquired, then you need to notify the other one that it has been released, and you can acquire the lock. But when it comes to explicit log, you have it is much more flexible. We can have a conditional interface introduced over there. Now, when to use logs? We can use it when we and in terms of when you're talking about synchronization, we can use it um, if you want to be simplicity is your priority. You wanted to write a critical section in a very small part in a straightforward way. But when it comes to explicit locking, when it can be used up is when you need some certain advanced features like try locking, fairness, and interruptible locks, right? And you wanted to have a more finer control of that particular locking and unlocking mechanism. Now in synchronize, there might be a possibility that it's not under your control, right? But in terms of explicit locking, you will get more control over it. Now you're performing very critical task and concurrent applications which are highly concurrent. uh, those we can use explicit blocks. Now, in summary, blocks are very essential tools for thread safety. uh, Synchronization easy, but it should be sufficient for most of the cases. But if you wanted to perform some advanced and you have a greater flexibility, we can make use of the explicit locks. So based on your choice and where your choice, you can make use of this particular locks and work on it. Let's look at the interview question. What is the difference between runnable and callable interface? If you happen to giving an interview for a multinational organization or a BFSI company, a banking and finance company, this is one of the important questions and must ask question, and it is one of the favorite questions around it. But if you happen to be a junior developer, if you happen to be a less experienced developer, you might not be asked this question, because this question is basically asked in the relevance of whether you have been working, have you worked on in a multi-threading environment or not, whether you have worked on a multi-threading application. So based on that, whether you have already, if you give an answer that if you have worked on it, you might expect this question. If you happen to not worked on it, there might be not possible that this question might be asked you, right? So let's look at what is runnable and what is callable. So if you happen to worked on multi-threading environment, you must be knowing there are two ways of creating threads, and one is using runnable and one is using the thread class. Now this is an interface which has got a run method. Now There's another method which is callable. So that was introduced as part of the collection concurrency package, that is java.util.concurrent. Now, basically, this two runnable and the callable, basically, they do a similar kind of work, but there is certain differences in it. Now, it's basically used for executing your task by the threads. Okay, so there might be many threads, so we can make use of the runnable implementation and callable implementation, and then write your own logic over there, and then we can run this. Basically, we'll look at the differences, what exactly it is runnable. So runnable, basically it is from the java.lang package, and callable is from java.util.concurrent package. Now, when you wanted to run a task on a thread, right, and you are not bothered about whether that particular thread is completed or thrown an exception, you can make use of runnable. Now, whether you wanted to know, like whether your task, whether you are given a task with a thread and you wanted to understand that it should return something or it should throw some exception. So in that case, we make use of callable. Now, with the help of the signature, we'll look at the signature, what exactly the difference is about. In run method, there is no exception. It is called, it does not return, it's a void method, and you cannot throw any exception. So basically it is void, it does not return any value, and it doesn't throw any exception. But basically, if you go with the callable, the method returns some value as a result, and then the signature is like it has got throw exceptions, throw the exception. So you can check, you can actually have the checked exception over there. The difference between them is that, as we already told, like it does not return, the runnable does not return, the callable returns. Exception handling, as I mentioned, checked exception cannot be thrown in exception handling. So if you are, if there is a problem, then you will not be able to identify what would have went wrong. But you can, of course, catching the exception is really difficult over there. But with the callable, you will be able to throw the checked exception over there, and you will be able to get that result as well. Basically, if when you want to use runnable, is you should be I mean, you are not bothered about the result, you are just worried about what task is to be executed. But with callable, you wanted to run the task also, and also you need to know, like some value should be written along with the handling some exception. Typically, threads can be executed by a thread as well, plus, and also by using the executor framework, a service, right? So, but callable can only be called by executor framework. You cannot normally call that. So here is the difference. Hope you got this. Okay, let's look at the next question. So this question is basically asked when might be in the middle of the question, middle of your interview, or like it will not be basically at the start or at the very end. But you may expect it at very end, but not at the starting. Uh, Interviewer would like to know whether when you have worked in your project, what kind of work have you done? Whether you have debugged, whether you have used log monitoring, whether you have worked on logging framework to understand how do you debug or come to a conclusion. If the system failure is there, how do you identify that with the root cause analysis of it, right? So in that case, he might ask you, he says that giving an example, saying, I will give you a scenario. I wanted to understand how you will deal with this, right? So he may ask you like what to do when you recognize a performance degradation, right? So it means basically whether it's your application, Java application, whether it's your database or a network, there is some glitch, there is some problem and some delay over there, and you wanted to understand where is the problem, whether it is application, whether it is DB, whether it is network. We'll look into those particular aspect, like what can be done over there when such situation comes in. Okay, Uh, so the very first thing is that we need to identify, or we need to diagnose the issue. There are some monitoring applications like New Relic, Dynatrace, App Dynamics, and Actuator. Spring Boot Actuator is there. So this will check. I mean, we can get those metrics of the performance. Like App Dynamics give you a clear-cut information of application, where it went, which database, how many requests. Those all information it gives. You can actually check the actuator logs as well. So there you will get like what kind of errors, stack trace, latencies, etc. Now identifying where the slowness is happening, right? Basically, when you are invoking any APIs, there might be a problem. Instead of 1 second, it is returning in 10 seconds or 15 seconds. So there might be delay over there with the endpoints when you are trying to invoke. There might be some high memory objects being created, so high memory usage is happening. Mm, when you are invoking any database query, it there is a tremendous increase in the response time. I mean, when it used to be queried, it used to earlier used to be returning in 1 second. Now it is returning around in 15-20 seconds, or maybe in 1 minute. That might be the problem. Thread contention or a deadlock. There might be a situation of deadlock, trying to acquire a log or get the data from the same table. There are, Java JVM metrics tools like, uh, garbage collection time, heap usage, thread count. You will be able to get that particular information from that particular tools. Uh, One is JConsole, one is Visual VM, and one is Java Mission Control. uh, Executing the database related things, actually we will be able to see like how many connection pools, how much time the query has taken time, like we'll see in the logs. We can measure the execution time, right, of the query. After we does this, we'll be able to pinpoint that particular root cause. The second thing is that we have to pinpoint that root cause. Now commonly the bottlenecks are around the inefficient code. You must not have improper not use the thread pools. You are when you're working with too much of threads, causing context switch. There are some database bottleneck as well, like slow query, unoptimized query, lack of indexes, connection pool issues, insufficient connection pool. You have given minimum connections, you have not given sufficient connections. There might be excessive connections already there in the database, which is not allowing it to acquire a log. So it is taking too much time also to run that particular deadlock. Due to the deadlock situation, it is causing too much time to run that particular query. uh, Third is like optimization application. Now once you find out that particular where you have the problem, then the comes optimizing it. So there are tools like profiler analyzing the code. There is your kit J profiler. There is Eclipse mat. So we it will identify which are the slow methods and memory leaks over there. So we can fine tune with the help of the garbage collection. We can adjust some JVM parameters over there. We can increase the memory. We can actually monitor the logs, garbage collection log, to understand what was the pause time. Optimizing the thread usage, like we can fine tune the thread pools, executor framework if you are using multiple threads to execute your task. You should be avoid. I mean, the lock should be handled in a very proper way. We can make use of explicit locks, reentrant lock, and any other locks. We can make use of caching. It comes in handy when you are trying to, in-memory cache, like, Redis is there, Gava is there, cache is there, which will reduce the number of hits to the database and unnecessary call to the databases. We can also make use of asynchronous process. So normally when you are hitting any API, it's a synchronous process. You get the response at the very same time. But we can make use of asynchronous processing, where we can make use of non-critical tasks which can be executed asynchronously, and we can make use of completable feature or messaging queues like RabbitMQ or Kafka for performing that activity. um, once you have processed or streamlined that particular thing, we can actually optimize the database related things. So we can analyze like what is the execution time of that particular query. We can rewrite that particular unnecessary tables, like full joins or any other things. Unnecessary join should be removed. If there are no indexes applied, we should be applying that indexes. And make sure that your query has the where clause along with the join conditions. It should like have proper indexes applied on it. We should, when you're using Hibernate or any other JPA specific implementation, right, there might be a problem that is called n+1. So we can avoid that by optimizing our query directly and executing it, and then we can make use of lazy loading feature of the application. uh, we can actually fine tune the connection poolings over there. We can make use of Hikari CP or Apache DVCP, so which will fine tune based on the application and the database capacity. Optimizing the transaction, so keeping transaction we consistently following the asset properties, and we have to maintain the consistency. It should be very quite short, and it should have a proper commit and rollback features enabled, so that unnecessary data or inconsistency is not there, and there are no logs problem, or there is no inconsistency in the system. We can also make use of partitioning and sharding, so splitting the table into the multiple partitions for a better query performance. If the data grows quite large, we can make use of this. Ultimately, like, we will be able to monitor and scale after we do this particular changes, right? So we'll be able to monitor those particular changes. We have to continuously monitor if there is a performance optimization done or not, or whether there is a degradation happening. So there are tools like Prometheus, Grafana, which will enabling the metrics, critical alerts. It will give you the metrics like what is the query timing, thread pools, etc., usage, etc. Uh, you can actually scale the resources as well. We can actually scale horizontally or vertically. So there might be, we can increase the number of instances behind the load balancer. So there is a load balancer. If there are multiple instances, it will load schedule the load on that when you are writing or reading, right? So it will be, if you are using, make use of any of the cloud environments like AWS, Azure, or PCF, we can make use of auto scaling feature of the cloud environment. Database are also scalable nowadays, like MongoDB, if you take, or any of the NoSQL, they are quite scalable, and we can add separate memory quite easily to them, so that when the load comes, when there is a throughput happening, high load, you can actually make use of the auto scaling feature, so that it increases your memory when it is required. So the horizontal and vertical scaling, both option is available in AWS and in any of the clouds. uh, we can then we'll look at the general practices, where apart from what we have discussed above the 5 points. uh, we should be writing a very efficient code. You should not unnecessarily do calculation or database calls. You should be doing the required things and optimize the best algorithm. We should need to make use of the shortest possible and the compliant code. So we have to make note of the kind time complexity. Unnecessary things should not be there. We should be properly load testing it with, like, there are Apache JMeter, Gatling, Locust. You should test your application with various load tests to find out the bottlenecks. Optimizing your JVM configuration. So this plays a very vital role when you are deploying your application in any of your environment. You should be able to understand what memory size it requires, like what is the heap size, thread stack, parameters, GC parameters, and all. Based on that, we can actually set the memory parameters on the production. We can make use of best ORM tools like Hibernate, where we can make use of lazy loading or eager loading based on the if there is no too much of data. So we can make use of eager. If there is a n+1 problem, we can make use of lazy. We can actually write the specific queries to like as we mentioned, we can make use of Redis as an in-memory database or cache. We can leverage distributed system. We can use of Redis, as I said, Redis or any other non queues actually, I would say. So this way we'll optimize, or we'll try to first identify, debug, and then change it, and then we'll start monitoring it. So these are the further steps, I mean, that we needs to be applied when in terms of identifying any issue. Let's look at the another question: how we can move from monolith to microservices. What are the design patterns used in the microservices, and domain driven approach and bounded question. What are these particular DDD and bounded context? So we'll look into it. Uh, Ideally, this is one of the favorite questions of an interview if you are attending an interview of Java, Spring Boot, microservices. Nowadays, every applications are getting modernized to microservices. So monolith, earlier it used to be a very heavy, large application, and everything used to be in a single monolith application, and you used to deploy that, and then you used to scale the whole application and etc. Right? Now, by dissolving it to multiple microservices with the domain driven approach and the bounded context, we can decompose that particular microservices monolith into a microservices step by step, incrementally. We'll start like what exactly is this monolithic and microservice architecture is about. So monolith is nothing but it's a quite heavy application, an application, everything it is got under one roof, and it is deployed as a single war file or a jar file. Every module, every applications module is deployed in a single war file or a jar file, and then application is accessed. But when it comes to microservices, these are all small independent microservices created, which will be closely communicating with each other, but they are loosely coupled. They are not into one system or a one server. They are separated into a different microservices, and they communicate with each other and communicate contact with each other using the APIs or a event driven architecture. Now, when we are trying to move from modern monolith to microservices, it's not a quick process, or it's not a one step, right? Multiple steps are involved in it. So it takes time from moving from monolith to microservices, and these are the factors which we need to consider. We need to first understand the current system, what is the code base, what is the data. Once we identify that, we can start decomposing that particular microservices. We can design and develop our microservices, which is under the certain boundaries. We can extract, we can deal with one service at a time. We'll take one module at a time, and one will design one microservice at a time. Now, when you're designing or microservices, you need to make sure that you're using the allowed design patterns, which are followed across the industry. So when you're designing any microservices, there will be involvement of API gateway, database per service, event-driven architecture, circuit breaker design pattern, service discovery, service registry, Saga design pattern. There are many more design patterns which we use it. There is two-phase commit. There are which is not recommended, but there are many other services design pattern as well. Now the domain driven approach and the design and the bounded context. So this is something which is comes in the decomposition of a monolith application. How we'll be able to create a certain microservices which is playing around certain domain and a bounded context, right? We should have certain criteria. I mean, the team should speak same. Uh, it should be referring to the same terms, and it should be communicating in the same language so that everybody understand what is happening, and they should be able to work as an integrated team. Uh, Potentially, we'll check for the challenges and the mitigation. So it's not a straightforward path. There might be very different challenges when it comes to moving from monolith to microservices. So there might be a complex system. There is a data has to be a data consistency. So across there are different microservices communicating over the network, over the API. It's quite difficult to maintain the consistency. So in all, like as I mentioned, these are the points we'll look into or we'll take into the consideration when we are trying to break or modernize certain monolith application. So moving from monolith to architecture is require, I mean, first of all, you need to plan it out. You need to understand the business domain. You have to sit with the architecture team, sit with the business team, the product owner, all this detail to understand what is the system is about. You need to apply certain design patterns as we discussed, API gateway, event driven, etc. So successfully migrating from monolith to microservices, you should have a clear understanding of domain driven. You should define those bounded context around the services, and you should step by step refactor the code so that you from, let's say, a module which has got 100 and then components, so you should be able to step by step decompose it, strangle it, and then create as microservices one by one, which we are closely integrating and communicating with each other. So after you deploy your incremental microservices, you should be start monitoring what is happening, whether the code is as working as expected, whether design is as expected, are there any glitch in the application, bug, or any other criteria which is not matching or not covered. So we need to check on the scalability, resilience, feature, lot many availability, high availability, loose coupling, high cohesion. These all are the factors which we need to take into consideration when we are designing a microservices. Hope you got this. Now, the next question might be what is the difference between monolith and the microservice, right? Uh, Ideally, as we discussed about, there is a whole lot of difference when it comes to uh, microservices and monoliths. So we'll look at it as we mentioned. So there is the architecture of this particular monolith and microservice is quite different when it comes to a design and overall development, deployment, and the maintenance. So monolith is completely one module, everything inside one application, but microservices is actually distributed and it is spread across multiple microservices, the functionality communicating with each other, and they perform their activities. So there may be a combination of on-premises or the cloud infrastructure uh, to make use of the high availability, scalability, low loose coupling, low high cohesion. These are all the features which should be as a part of the monolith, and there should be a high a low latency. So you should be able to store different kind of data. It supports NoSQL and also the SQL. So we should be able to deal with the complex system. It's deal with that. I mean, complex team. There might be many teams sitting over there and working on. There might be a different tech stack being used in different microservices. We'll all discuss one by one. So before we jump in, right? So we'll discuss like what would be the structure of the monolith and microservice. There is a difference, right? So the structure wise, they are very quite different. When it comes to development process, also, uh, monolith is quite easy for adding the features and testing it, but when it comes to testing, it is quite difficult. But microservice is quite difficult when it's trying to testing, and but it's quite you should be maintaining that system in a very highly available and loosely coupled, so that you'll be able to properly integrate in tests, all other tests which can be executed. The deployment in monolith, it's a single WAR file or a jar file, but in microservice it is spread across multiple microservices. It's a challenge, right? Maintenance is quite easy when it comes to the server deployment or enhancement, but in terms of microservices, we need to invest a lot when it comes to maintenance. When you are updating any system, right, we need to test it. So microservices also we need to certainly specific microservices which is undergoing the changes, we need to update it. Tech stack can be quite different, but in monolith, uh, we need to make use of the single tech stack. But when it comes to microservices, we can make use of multiple tech stack. Multiple team can use multiple tech stack as they are working on the different microservices. Uh, Complexity wise, monolith is less complex, but microservices is quite complex because it has got multiple services, login, monitoring, database, transaction, different factors we have to consider. It should be highly available, it should be on the cloud, it should be scalable. These all things should be taken into consideration. Now, when we should be choosing monolith and when should be you choosing microservices, we'll discuss about that part. Now, if your application happens to be very small and a medium, right, and it's quite simple, small team is there, there are clear boundaries around the systems, and like uh, design patterns of monolith, like we can make use of it. It's quick to develop and deploy. There is a very quite strict deadline, okay, which will allow only focusing on delivering the functionality rather than managing the complexity of the microservice. In that case, we make use of the monolith architecture. Now, when we can use microservice architecture is, let's say you have a very large application, complex application. It grows as in when, like, when you're breaking the monolith application, or when you're trying to design a very large system. So it's better that microservices are it should be maintained properly, it should be scaled up, it should be flexible, etc. We should be considered. Now, independent team can work on it, so that nobody is stopped out for the deployment process. It has got their own team, their own tech stack, working on a different functionality, so that the iteration is quick. Customer gets early feedback. Now there can be a separate autonomous applications to be deployed. That we can introduce a continuous delivery or a deployment of a migration, to frequent changes which we follow in the agile, so that we deliver the large chunk in a step-by-step process, okay, which can be independently worked and deployed. Hope you got this particular question.
Let's look at the another question. When new feature is added by the client in the system, how can we estimate and come up with the efforts, development, testing, and delivering of to the client? So basically, this question is around wanted to understand how you go ahead with the estimation, what how you do the development and delivery of a requirement. So basically, uh, when a new feature is been added, right? So there are estimations effort required for the development, testing, and the delivery, right? So this will be the phases involved in a delivery of a feature. So this process is very crucial and it requires planning, the resources, uh, managing the client expectation, and we have to ensure that it is delivered on the timely manner. So basically, the very first thing is we need to first understand the feature, what exactly the feature is about. Then, once we get that the clarity of what exactly the feature is about, we break that into a features into a task. So we'll break down into a small things, so that it is easy to develop. Now, once we break down that, for each of them we will actually use different methods to for estimates, like the 3 point. There is also different agile what we use, right? So we make use of that. We analyze that and we estimate those with the help of that particular methods. And there is an estimate for the development effort. We make it. We ask the developer to read the story and come up with the dev estimates. Then we ask the QA team for testing efforts, how much time it will take. Then collaboratively, when development is done and the testing is done, how much time it will take for the delivery, right, to the client. Now, in that actually we also add the buffer time, so that let's say the development effort is 8 story points or 8 days. So we'll include some buffer inside that, so that if there is any unnecessary, let's say somebody has gone on leave or some medical emergency has come in, right? So we take into the buffer of some time, and ideally we'll consider based on the days, right? So the story points and the productive efforts, productive of each team members. Let's say he's working 8 hours, right? So we will consider around 7 hours of productive work. Let's say we uh, leave 1 hour of their non-productive hours. So we'll consider 6.5 to 7 hours of that work, and then we'll estimate how much time it is going to take. So we'll include the leaves, the weekends, and everything. We'll exclude that, and then we'll communicate to them. So once we start the development, we'll be able to, once we communicate to them, we'll take it to the sprint. We do the development, we will track that particular progress, and then we'll, if there is any changes, we adjust it. But this is what the normal flow would be about, right? So estimation efforts is like in breaking down, right? As I told, it will the smaller task. Hope you got this particular concept. Now, when it comes to microservices, this is one of the favorite and the important questions when it is asked around event-driven architecture. So this event-driven, this is one of the design pattern, basically Saga design pattern. And basically, there are two types of Saga design patterns. One is orchestration based and one is choreography based. So we'll look into it. So it is used for this pattern, the Saga design pattern is basically used for managing the distributed transaction across the microservices. So traditionally, when we used to code and work, right, the asset property don't work at the multiple servers, right? Because it was difficult to your application was deployed over there, and then across the server it was very difficult to manage. Now Saga, what exactly the Saga does is that it will break the long process into a small, into a series of smaller, and each individual transactions isolated actually basically, and it is executed by the different microservices. So if one of them actually fails, right, so there will be a compensating rollback. Now in transaction there are two things, one is commit and rollback, right? If there is some failure, it should be rolled back to the previous state. Now, as I mentioned, one is orchestration based and one is choreograph based. So what is orchestration is, it is centrally managed. So there will be one service which actually will be taking care of that particular transaction. So that will manage and communicate with the other services, and then it will manage, and then it will commit that. Now choreograph base is around decentralized, so it will like each individual microservices will be part of that particular transaction, and if there is a certain failure, it will roll back inside that step. So let's look at that particular orchestration base. In this approach, there is a centralized service which will manage and coordinate between all the interaction and the process, right? And first, it will send the command to the other services. Now, service is what they will perform their activity and then reply that either it is failed or success. Now it will decide the next set of action. Once it is received, right, the calling service will decide the next set of action, and it will also trigger the next set of transaction if needed. This is how it will work. Now choreography based, it is decentralized, as I mentioned. So in this approach, services will communicate with each other directly. There will be no centralized thing, as there was a single service which was communicating with each other. Now in this, each microservice will directly communicate the events and then publish the events. And there will be certain listener which will be having which will listen to that particular service and perform their task, and then it will publish it. So it will basically, how it will work is that it will publish the events when their tasks are completed, and other services will listen, and then they will perform their next set of actions. So if something goes wrong, okay, it is not received in certain time or it goes wrong, so there is a compensating event published. So this is one of the most used design pattern. And basically, if you compare, there is another design pattern which is two-phase commit. It is not recommended, but this is what it is recommended. And basically, uh, it is it is done with the help of Kafka, the message broker, to achieve this particular functionality. uh, when you are actually working on a software development, right, there are two kinds of approach. So the question was asked to me, like, what is suitable, whether it is top to bottom or a bottom to up approach. So basically, let's say you have a module. What you do is that it's a combination, and then you break that particular into a sub modules, and then sub modules inside, ultimately at the very ground level. So that is top down approach. But ultimately, the other approach is bottom to up. So what we design with the more granular level, ultimately to the top, the high level module. So this both approaches are used in the software development, and they are dependent on the nature of the project. So complexity, the business goals. So they have their own pros and cons, but it depends on, like, how your project is about. Okay. So top down approach, as I mentioned, it is designed starting from the highest level component, then it progressively broken down into the smaller modules and sub modules. So we define the overall system architecture, key module, then we decompose, breaking into the high level components into a smaller, implement and start the coding in there. So it will go from the high level design. Now, top bottom to up. So in this approach, the development starts with the designing and building the lowest components, very large components, and then they are integrated and merged to a larger modules, and ultimately the system is formed up. So we'll develop the core features, reusable components, libraries, such kind of things will ultimately integrate into one of the higher or modules one level above, and then ultimately at the very top we can actually build a system. So this is how it will be done. So the overall, the top down is suited for the large fixed base project which has got crisp clear requirement. But let's say you doesn't have any crisp requirement, or like requirement goes on changing. So bottom to up is what required, because it is as we normally work on the agile, right? So it's quite dynamic, and the features may change, the requirement may change, it's quite flexible. So bottom to up is quite flexible when it comes to the development. We can also go ahead with the both approach of going up the hybrid way, actually combination of both approach, to make it as complex, for suitable for complex application scalable system. So based on that you can choose on that. When do we use a sequence diagram? Now this is one of the design UML diagrams which is used for designing the system. Let's look at the another question. uh, when to use sequence diagram? Now if you have heard of sequence diagram, it is one of the UML diagram, and basically it is used for in the software development to get more clarity on the use cases and the system, how the control flows from one component to the other component, and ultimately how it returns. And it gives clarity on we are covering the each component, and ultimately we are achieving our functionality. Now, as I mentioned, it is used in the software development for to get the control, to understand the flow of the control in the system. Where exactly we'll be using this? So, when you are doing the requirement analysis, you need use case detailing, system designing and architecture. When we are doing the whole designing of that part, we need to know the process flow. Then we are designing, modeling it during that time, right? We can use it when you're integrating between the two systems. We can do that, or multiple system we can use in the code design and the implementation planning also. When we are trying to debug or troubleshoot something, we try to understand where exactly it went wrong. So in these use cases we may use the sequence diagram. It helps to get more clarity, and also it helps the developer or the person who is actually working on that particular requirement to get more clarity how the code flows, so that before the development he is crisp clear on the development what he needs to do and what are the use case he needs to cover. Hope you got this particular sequence diagram. uh, Explain Spring security. Now, you must be knowing Spring is has got many modules, and one of them is the very important thing is security. Spring and the Spring Boot, it has got a module called Spring Security. Now, explicitly Spring, if you see it, there are versions like 6 plus, which has now the latest versions, and Spring Boot it is 3 plus now. What exactly this Spring Security is about? Now, if you see, it is one of the framework, would I say, where you can secure your applications, Java-based applications, or uh, basically. So it provides authentication, authorization, and there are. Let's look into this particular question. Explain Spring Security, how Spring Security works. Ideally, uh, when you go for an interview, this is one of the most frequently asked question. And if you are not a junior developer, you are an experienced one, let's say 4 or 5 years, this is the compulsory question which is asked by the interviewer. uh, if you are a junior level developer, he might skip this particular question. He will just ask around the core concepts of Spring and Spring Boot. But Spring security is one of the important features, and every uh, experienced developer must be aware of, because nowadays, with the microservice architecture in picture, it's very important that you secure your microservices when you're communicating between the microservices, or your system is just behind the API gateway. It's quite important that you know the Spring security, how it works, and what are the components inside it. So it is one of the framework for the Java-based applications, and it covers authentication, authorization. It also cover ups against the common attacks like CSRF, XSS, and some session fixation. So it is highly configurable, and it integrates seamlessly with Spring Boot. So one of the key features, the important features of Spring Security is about authentication. So it identifies the user's username and password, or like any, whether a particular person is an authenticated one. So basically, once he is authenticated, then only he will be allowed to go for the next step. So there are different ways to achieve this, and it's Spring Boot support all of them. The next step is authorization. Now, after authentication, the next step is what resources you can access in this application, what URLs are accessible to you. So those are based on the roles and the permissions. So you can actually configure those inside the Spring Boot application. Now we can also manage the user session, which has to be it is called session management, very securely. Encoding. So password also, there are certain algorithms which like decrypt, encoder. There are different of them. So which will encrypt our password. There are certain ways as well where we doesn't need I mean, to type in username password when you're trying to authenticate, but there are certain where we diverted to the server, so that we, like, we can make use of the resource servers, the servers like Google, Facebook, to log in into the system, and that will allow that particular systems to log in and then do their further activity. CSRF protection, so it prevents cross-site attacks, forgery attacks, and it integrates well with authorization framework, that is OAuth, and using the JWT. So it provides the modern security protocol. It is one of the most used security framework. Now, as I mentioned, authentication, authorization, security context, filter chain, user detail service, granted authority, and password encryption. These are all the features which are we required to configure or use it, which is made available by the Spring Security. Now let's look at the next point. If you see, as I mentioned, there are two authentication and authorization. So first, when the user logs in, right, the user submits the credential, like let's say the form login form based is enabled. So the username password he types in. There is an authentication manager in the Spring Boot which checks for the configuration, like if we have configured LDAP, database, or in memory, it will authenticate, it will check for that, and it loads the user details that should be configured. Okay. Now after this is successful, so if it is valid, so it will store in the security context folder. There is one in the Spring Boot, it is there. It will store that details, and if it is invalid, it will actually the failure response will be sent to it. Now after this comes the authorization work. Now after authentication, as I mentioned, Spring Security make use of the roles and the permissions which are granted in the system, so to access the resources. Now these are applied using the annotations like @pre-authorized, @secured, @configuration in the filter chain. So filters play a very important role when it comes to security. So it's quite, as I said, Spring Boot security is quite secured when it comes to providing security, and as I mentioned, it will be used for authentication, authorization, and some protection against the common vulnerabilities. Okay, uh, let's continue. This is one of the, I think, most frequently asked. So if you got any developer, any person who is asked, he definitely will say that he has worked on the design pattern and when he asked like which design pattern, he the first things which is come to his mind is singleton. Now many people consider this particular singleton as an straightforward, and there might be I've been interviewed by many interviewers where they confuse us with the questions which is revolving around singleton, because singleton class what we write, there are different ways to write it, the best way and the weak way. And also when it comes to singleton, we can actually break that with a different ways, like reflection, serialization, cloning. Now in order to stop this particular singleton feature to be broke up, we we make use of the best way to write it, so it is not breaking it. We'll discuss those things. First, what is singleton? Singleton, you already know. It ensures that when you create an instance of a class, it is created only once throughout the application. It is accessible throughout the application. You doesn't need to create it every time when it does object is required. So it is globally accessible to everybody. uh, like there are scenarios where like database connections, logging, which will initialize at once, and you just make use it everywhere until the application is up. uh, but why do we require a singleton is like we wanted to have a proper resource management, so that we doesn't create unnecessary database connections or files. It is globally accessible to everyone, so that uh, anywhere it can be called up by us just by initializing once. It's quite memory efficient when it comes to let's say you're creating only once, so it is quite efficient, and it helps saving memory instead of creating number of instances when required. Also, it is quite thread safe, because it is no matter how many threads require the instance, it ensures that only one once the instance is created, no matter how many threads are requiring it. uh, One of the best, there are different ways to write singleton. One is eager initialization, lazy initialization, thread safe singleton, which is making use of synchronized method, double checked locking, that is recommended for high performance in multi-threading environment. One is bill book singleton, that is best practice, one of the recommended, but ultimately the best way to write is enum, because it will not break using the reflection or any of them. So there is no way to break this particular thing. So the best way to write singleton is write using the enum. Uh, how do we write that? We first um, create, I mean, we get that instance method. We make the constructor as private. We create an static variable, and then we create that particular instance with the help of that particular get instance method. So there will be no getter and setters and other related to that particular instance. We can directly get that instance either eager, lazy, or by the help of the now, date API is one of the features which are added in Java 8. There were many more features included in Java 8, but date API and time API is one of the important features which was introduced as part of the package Java time. So there were some limitations with the older date and calendar features. So this it provided a immutable and a thread safe version of the APIs, so which will be more suitable to work with, and it provides dates, time zone, etc. Now I'll tell you what was the problem with the API. It was mutable, first of all. So it was quite vulnerable, I would say. It was unsafe. Okay. Anybody could change that. Now, complexity. Working with dates require extensive use of calendar and many. calculation things to uh, do the calculation. It was not simple, and also it was not consistent across. So the condition was different, it was not maintained properly, and it did not there was a confusion between the time zones. It was not clear cut for the user, so it was kind of error prone. After that, the solution, which was after many years, it has been solved, and it brought up with the date and time API, which is mutable, immutable, which is thread safe, and as per the design, and it's clear cut, right? It's ISO standard related, so clear methods are provided with the names. It's quite supportive. So when you try to change something, it is quite supportive to make that particular changes. It supports time zone, okay, which was not particularly easily available, I would say. Hope you got this particular date and time API. So these are the all classes which are there. Like if you want to get the local date, local time, local date time, zone related date time, instance, it is used for epoch, right? So duration, how many seconds, period, zone ID. These are all introduced in try with resource. So this is one of the important features introduced in Java 7. It is used for automatic resource management. Now, what used to happen prior to that is that we used to create the resource, but we used to forget to close that particular resource, and it was ultimately going out of memory, or there was a memory leak happening. So, to in order to prevent that, like it has introduced a try with resource, where you write that particular code section with the try with the resource, and JVM will take care of the automatic closure of the resources. Now when you're creating any file, socket, or database connection, so it doesn't need to take care of that particular resource leak. It will automatically be taken care by the system. Now it's quite easy, to write that. It's automatically close this that, and there's a proper resource management happening, so you doesn't need to worry about that particular part. It will be automatically be taken care. Just you write that particular try catch, it will automatically be taken care by that particular thing. So you don't need finally clause to explicitly write it, or if you forget also, it's quite manageable. And also, not only single resource, we can actually have multiple resource to be declared by the comma separated. Okay, hope you got this. Let's look at the another question. What is intermediate operation in Java 8? If you have heard of Java 8 stream API, it was one of the important features introduced. Under that, there is uh, first we convert that particular collections to a stream, then we perform the intermediate operations, then we perform the terminal operation. Now what exactly these intermediate operations are? There are certain methods which are executed, which will produce the stream. Ultimately on top of that, there will be a uh, terminal operation involved. Now what are these particular methods? uh, these will return, as I mentioned, it will be returning a string, but until you are calling the terminal operation, it will not be executed. So it is quite lazy. It's quite lazy. I mean, when it comes to saying lazy, right? It will not execute until you are calling the terminal operation. Now there are filter method, map method, flat map method, sorted, limit, skip, peek. These are all intermediate operations. What are the important characteristic of an intermediate operation is that it's quite lazy. So quite lazy as in it will only be executed when there is a terminal operation performed. It will return use the stream, which will allow you to method chaining. That you can do different set of method chaining to return the stream. So filter will not be dependent on the previous, so it will directly perform on that part. But let's say there are different methods like sorted, it will take the input from the previous one, it will sort it, and then it will produce a result, right? So ideally, filter method, just if you take an example, it's a predicate. It takes an input as a predicate, uh, and it helps improve the memory utilization. And if you want to perform some operations, it will be quite handy when it comes to the intermediate operations. So it is of great use, the methods which are provided in Java 8. Hope you got this particular intermediate operation, what exactly it is. uh, so first, the collection is converted into stream to intermediate operation, then intermediate operations are performed. On top of that, there is a terminal operation. Thank you for watching.